Hey everybody, it's Tony from Adafruit, and I wanted to do a stream all about a lot of Python stuff and some new stuff that we have with a lot of the Python libraries that we have here at Adafruit. So we'll kind of go through a bunch of interesting things that we've done. So we've broken out an old library of Python code into individual Python modules. They'll be easier to maintain, it's easier to keep track of issues with things, easier to add new libraries and stuff in the future, and they're also on the Python package index, so now you can install them a little more easily using the pip command. But maybe even the bigger news though is that I've gone through and I've actually ported all of our libraries to work with both Python 2.7, which is kind of the current version, and then Python 3.0, which is the newer version of Python. And it's a little bit of work, and I'll go through in this stream like some of the issues I ran into and hopefully give some tips on how to port code from Python 2 to Python 3 because there are a few little gotchas and some maybe surprising issues to deal with for it. So, let's just kind of dive in. We'll get started here and go through what we've got to show here. So let's switch to kind of the main view here. So up in the upper right, so I just have a Raspberry Pi, and it's connected to a couple different sensors right here. Up right here in the middle, this is an MCP 9808 precision temperature sensor. Nice little I2C temperature sensor, more accurate than some of the low-cost ones. This below it is a Max 3155, I believe. We'll see the exact number. Thermocouple sensor. So this is a little K-type thermocouple connected to it. And then this uses a SPI interface, so more of a serial protocol to talk to the Raspberry Pi. So also again, a very useful little temperature sensor. Because it's a thermocouple, you can do a lot more interesting things with the temperature probe here. And then this is a set of WS2801 RGB LEDs. So these aren't NeoPixels. Those are actually the 2811, 2812 style. These are maybe older, or maybe they're newer, but these were kind of an older version of NeoPixels that work well with the Raspberry Pi, because for a while the Raspberry Pi wouldn't work with NeoPixels. It has a very exact kind of timing signal that you need to send to light up NeoPixels. Versus these pixels, they have a data and a clock line. So like the NeoPixels just have a single line that's both your data and the clock. These have a data and a clock, so it's a lot easier for Raspberry Pi to control these. And this is an example of code that we had in this older Python code repository. And I'll show you what we've kind of done here. So normally, if you wanted to use, for example, these WS2801 lights, you would go to this repository, the Adafruit Raspberry Pi Python code. And I'll put links in the description when this goes up on YouTube, so you can look down there and see links to all the different pages and things I mentioned here. Now, if you went to this before, you probably saw a repository that looked like this legacy branch. So inside of here, there are a bunch of different directories, and all of this is just Python code to talk to different Adafruit devices. So, for example, you can see, like, here's this LED pixels directory, and inside of here was a very simple little script that can control these WS2801 style pixels. There's other libraries in here, like here's an ADS 1x15, which is a nice little analog to digital converter. So this is a little library to control it. Now the tricky thing is that all of this code is in one repository, so you can see like there's a bunch of issues, and we need to go through these and clean these out hopefully. But it's tough to tell, like, okay, what has a problem? Is it just the ADS library that has an issue, or is it something else? It's also a little tricky in that these aren't Python modules, so they don't have like a setup.py. So you can't install these easily and then write your own script to use them. You kind of have to take the code and like copy it into your script and reference it locally, versus a Python package. If you're using like the Flask library for a web application, you can pip install that, you can download it, you can install it globally so your code can reference it. So it's a little trickier to use, and we've created other Python libraries since then that actually aren't in this repository. They have their own GitHub repositories, and they have kind of these setup.py files, so they act as modules. But for a while, we've wanted to come back and actually break all of these apart, and that's actually what I've done. So if you go back, this is now the new master branch of this repository. And when you go here, you might be kind of surprised, like there's actually no code in this repository anymore. So there's just this README file that kind of explains what's happened here. So what we've done though is instead we've taken all of those old libraries that were just directories, or not even libraries, they were just script files basically. And we've actually turned them into Python modules. So if you go, for example, here's the ADS 1x15, so here's its new location, and so there's a little table here that kind of lists the old code and then the new location. And if we go look at this thing, now this is a little bit more like a real Python module. So it has this setup.py file that kind of explains all the metadata for it. So because of this setup.py, you can install it on your Raspberry Pi, and then you can write a script that just references it. There's example code inside of here. It's like, a simple example of using the ADC right here. And you can see, it's just importing this Adafruit ADS 1x15 module. And you can do that because it's a proper module. It's been installed. I don't have to have the source code inside of there. The other nice thing is because this is its own GitHub repository, it has its own set of issues, its own set of pull requests. So a lot easier to manage than just a deluge of random issues and things in the other repository. So let's see. Let's go back to the main repository. So basically inside of this README, there's a nice little table here. And it just points to, okay, if you were using the old BMP85 code, here's where you can get a new proper library for it. It also mentions that this stuff is on pip, or the Python package index, which is kind of the global package index for Python. And it gives you the name. So you can actually pip install this Adafruit BMP library, and that will be as if you had downloaded the code from GitHub and done the setup install on it. Now the one big difference though with using pip is that it doesn't install any of the example code in the library. So like if I go to this BMP module, there's an example directory that has a few examples in here. When you pip install, you don't get these examples. I didn't see a way in pip to have like example files that are installed in some central place. I think the setup tools have a concept of like ancillary files, like extra files that aren't a part of your script. But I don't know if there's a concept of like, because on a Linux system, where do you put example code? Like you could put it in /opt, you could put it in like /user local share, something like that. There's probably some proper way, and I'm just not familiar enough with it. So for now, I still kind of recommend installing things from source, like download the GitHub repository, run the setup.py, because that way you'll get example code and other things that are inside of here. You'll have the GitHub repository, you can update it easily, but it doesn't hurt. You can still use pip to install a lot of these things. And then I also kind of mention in here, if there was a guide that used these devices, I give a link to it. And those guides I've gone through and I've updated them so that they should use these new libraries now and show you how to install this stuff. So it should be all good to go as far as, if you use the older Python code, you just go to the repository now and it'll point you to the new libraries. Now the new libraries, I did make a few little tweaks to like the naming. I tried to make them all consistent with kind of the PEP8 style of naming. So in a lot of cases we had like a camel case of name where you have like lowercase and then uppercase letters for like function names. I changed those to be more of all all lowercase with dashes or underscores to replace spaces. So slight little tweaks, but the basic functionality is there. And look at the example code in all of these libraries. That kind of shows you how to use these libraries. So if you are using them right now, you might need to do a tiny bit of porting to make it work. But I think you'll see the advantages of these libraries outweigh kind of using the old code. And one big thing, because I'm sure if you were using the old code, there might be a very valid reason that you still need it. So there's a legacy branch in this repository, and it's down at the bottom of the README. It mentions it, and so I just took a snapshot of the code as of 2 days ago and threw it in the legacy branch, and so it's there. You can still get to it. Now we're not going to maintain this old code. We've broken it out for a reason so that we can maintain the new code a little more easily. So just something to be aware of. And then I also kind of put in here too links to other Python libraries that we've created that weren't a part of this older code, but still could be pretty useful. So things like a couple of the devices I have here, the MAX 31855 thermocouple sensor, the 9808 temperature sensor, so all kinds of cool stuff. And I'm thinking I'll try to make this page maybe like the master list of all the Python hardware libraries that we have. Mostly just so that I can keep track of it, because we have about like 25 or 26 libraries now. And so it's getting to the point where, okay, I need to, know like if there's some change I need to make to all of them, have a good list somewhere of every library. So, this will try to be the spot. And then this also mentions if there's a pip install package, like if it's on the Python package index, this gives the name that you can use to install it. So that's one cool thing. So we've split this out. And like I mentioned before, so one thing, because as I split this stuff out, I had to kind of go through and test each of the modules, with the hardware, make sure it still works, update things. And as I went through testing stuff, I kind of thought, well, this is a good opportunity. I should port the code over to work with Python 3.0, which is kind of the new version of Python. And you might have heard a little bit about it. It's actually been out for a while. I think 2008 I read is when the first version of Python 3.0 kind of came out, and I think there were beta versions before that. And it's been a little bit of a slow transition, but it's been picking up a lot of speed. And the big thing is that Python 3.0, it purposely broke compatibility with Python 2.0. It's a major version change, and so they want to make these breaking changes for the better, because there were things they realized in Python. You don't get everything right the first time, unfortunately. So they learned some stuff in Python 2 and thought, you know what, we should do this better in Python 3 or in a different way. And it's really tough if you're trying to be backwards compatible. You could write a whole ton of code to try and handle those old cases and then handle new cases, but it's going to restrict you a lot. It's going to be painful. So they kind of said, well, look, let's just make a whole new major version. We'll break things where we need to, and there's good justifications for breaking stuff because they want to make things better. But it's been a little tough because, if old code doesn't support Python 3.0, then as a user of that code, you're kind of stuck. It's like, well, I can't get all the fancy new stuff in Python 3, because one big thing is for the last year or so, Python 2 has kind of been in like a stable state. There's no new functionality they're adding. I think like critical security issues they'll patch, but you're not getting cool new features, versus Python 3 is where all the new cool fun development of new stuff is happening. And there are some big things in Python 3, like there's a whole asynchronous execution system, which is from what I understand kind of similar to like the Node.js style of having like an event loop. So there's really neat stuff for like server side, and just in general they've made a lot of little improvements to the language. Also another big thing in Python 3 is Unicode support, and in Python 2 initially it didn't have any Unicode support, then they kind of hacked it in. But if you've done stuff with text in Python 2, you've probably got these really cryptic errors of like, I can't convert between text and bytes. So in Python 3, they started with a clean slate and hopefully made it a little bit better. Luckily, I don't deal as much with text and Unicode stuff because it gives you a headache after a while of all these issues. But it's supposed to be better in Python 3. So, and for a while, our Python libraries that we've had, unfortunately, they haven't really supported Python 3. For a few different reasons. One is that most of our libraries require things like using I2C or the SPI interface, and those use different modules and different libraries in Python, which for a while none of those libraries supported Python 3. And so, it's like we can't really do anything with our libraries if the things we depend on don't support it. But a lot of that has changed. So I've gone through, and actually a lot of these libraries now work with Python 3.0. So the big thing is that all of the Python code listed in this list here, these are basically all of our hardware libraries. They now work with Python 3.0, and I'll walk through a few demos of showing it off, which is pretty cool. So, and from my testing, I've used all of these libraries in the past week or so with both Python 2 and 3, and Python 3 seems good to me. Like everything works. I didn't run into any major issues that weren't easily overcome with just fixing a few things and how they changed some of the syntax. So yeah, I think it's a green light to start playing with it. The major things like SPI, I2C, GPIO access, like the RPi.GPIO library, all of those support Python 3. Now for I2C, I'll show you the old module that I used to use for that, the Python SM bus library, doesn't support Python 3, but I actually created a new library that does support Python 3, and I'll show you a little more about that in a little bit. But I think it's ready to go. I think this could be the year of using Python 3 as kind of the standard version of Python for Raspberry Pi stuff. And at the very least for all of our modules, and going forward too for new modules we create, will at least support Python 2 and 3, so that if you want to go crazy with Python 3, go for it. If you still have to use 2, no harm in that, because you'll kind of see like you can support both versions. You do have to do a little more work as a library creator, because there are certain cases where it's like, well, this works in Python 3 but not in 2, so now my library needs to figure out, on 2 do this, on 3 do that. But it's not as bad as you might think, and there are actually some libraries you can use to help with that. So first I was thinking, let's jump in, and if you've never used Python 3, I'll show you how to install it, how to run it, and then maybe I'll go through a few of the little gotchas of, changes in code between Python 2 and 3 that might trip you up. So I've got my Raspberry Pi here. I'm connected through SSH, and I just have a terminal here. Now, when you run Python on the Raspberry Pi, because it's installed on all versions, you'll see it runs a little interactive terminal, and this is showing the version. So this is Python 2.7.9. I think the current version is 2.7.11. But like I've said, I think ever since Python 2.7, all of these minor releases have been just like security fixes. So there aren't like new features that you're getting in the newer versions. But anyways, this is your standard Python 2. So you can say, hey, print hello world, and everything works, and it's standard stuff. Now, by default, Python 3 is not installed on the Raspberry Pi, and so what you want to do to install it, first do sudo apt-get update, and then this will go through and just update all of your packages to make sure that you've got a link to the latest ones. And by the way, you probably want to use the Jessie version of Raspbian. I don't even think they have links to Wheezy anymore. Jessie is kind of the way to go. It's the modern version. Everything seems like it works with it nowadays. So it's always good practice. Update your packages, make sure you've got a link to the latest ones. And then you want to install a couple packages. So the big thing with Python 3 on the Raspberry Pi right now is that you can have both Python 3 and 2 installed at the same time. They have separate names, and they're actually totally separate. So if you install a library under Python 2, it won't be installed under Python 3 and vice versa. So it could trip you up a little bit. And there's actually like two versions of the pip package manager. There's one for Python 3 and one for Python 2. So just something to be aware of, but you'll see the packages as I use them here. So then to install Python 3, you want to do sudo apt-get install, spell that right, Python 3. So that'll install the main Python 3 interpreter. And then you probably also want to install Python 3-pip. So this will install the pip package manager for Python 3 because you can't use the Python 2 version of pip to install Python 3 libraries. Now, I've already installed these, so it was a quick little thing, but it takes a minute or two for it to download. And then to run Python 3, you just type Python 3, the number 3 after it, and that's going to run the Python 3 interpreter. So you can see here, this is Python 3.5 or 3.4.2. I think 3.5, maybe even 3.6 is the current version of Python 3. So this is a little bit older. This is because Raspbian Jessie, it's not a rolling release. It doesn't pull in the latest versions and stuff. But it's still it's Python 3, and it's good enough for what we want to do. Now, when you run Python 3, it's pretty similar to Python 2. Like, you get this interpreter, but you might notice like the one big change that it's always mentioned, but it's not a big deal, is the print statement changed. So if you do print hello world again, didn't have the right thing, but you see this fails. So missing parentheses and call to print. So they changed it in Python 3. You have to call print like a function. So you have to use parentheses here. So print hello world, and then now this works. So, sure, this might have caused some pain early on when you had a bunch of Python 2 scripts, but it's a pretty simple find and replace, I think, to just find any script that has print space and just turn that into, adding parentheses to it. But it's changed, something to be aware of here. Now you can actually, so if I exit out of Python 3, I'll run Python 2 again. And after you install Python 3, you can use Python 2 just using the same Python command. So like 3 doesn't replace 2. It just kind of sits side by side with 2 on the Raspberry Pi. But for example, I can actually use the same syntax in Python 2. So if I say print hello world, that works. The reason this works, it's not because they went back and added print support. They actually did, but there's a special way you have to enable that. It's the way that this is working is that Python is looking at this as print the tuple hello world. So like, putting this space in here, this actually will work because it's not interpreting print as a function. It's still interpreting it the old way in Python 2, but it just so happens that when you put parentheses around something in Python, it makes it a tuple, and print is okay to print a tuple. Now, one thing in Python 2 that you can do, you can say like hello, comma, world, and it will insert a space in between there, and you can put comma, 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 and have all kinds of things and print them out. You can't do that with the kind of tuple syntax like this. So if I do hello, comma, world, it gets confused and it prints out the tuple hello world. But that comma syntax in print, I don't use it very often, mostly because when I'm assembling things to print, usually you want to use a format string. So, for example, like let's say I wanted to print out like two variables with a space in between them. I can do 0 and 1, and then dot format, and then print. Here's hello, and then here's world, and this will work just fine too. So this is kind of the way I think about it. And I think in Python 3, let's go back to Python 3. I'm not sure if you can do that comma syntax inside of print. Let's just see if it works. So let's try hello world. So it looks like you can in Python 3. But I like the string format kind of syntax because usually when you're jamming variables and things together, you might want to format them in different ways. And so, using that format string is just a little easier. So the print thing, that's a big thing, but it's not as big of a deal as you might think. You can actually go back in Python 2. I think if you do from __ future _ import print, maybe you can't do that. So there's a way, and I actually have a link to a good little guide, but you can bring in the new Python 3 print behavior into Python 2 so that you can't call print without adding parentheses, which is pretty smart because if you have a big Python 2 like script or library and it's real complex and there's a lot of code in there and you're worried about porting it to Python 3, like what might break, flip on this new print behavior and see what happens in your script. Does it run? Do you get errors? And it might help you out there. So that's one thing. Now another big difference here, let's see, so I'm in the Python 2 interpreter. One big change, and this affected a lot of libraries that we use actually, they changed how division works in Python 3. So in Python 2, division kind of tries to infer if you're using integer or floating point variables, and if they're both floating point, then it'll do floating point division where you get like, a real number result. Whereas if they're both integers, it'll do integer division, which truncates, so if you do like 10 divided by 3, you don't get 3.333, you get 3, which is, the integer result of that division, taking the floor of that. And so, whereas in Python 3, they flipped it, and now all division by default is floating point. So even if you have two integer arguments, like 10 divided by 3, you're not going to get 3 as a result, you're going to get 3.33333. Which doesn't sound like that big of an issue, but in a lot of cases you've written a script where you might expect and require integer division to happen. You might be depending on it. You might not even realize you're depending on it, that math, you're truncating it or taking the floor of that result. And it actually causes problems too, because now the result of division is a floating point value, and you might do another operation on the result of some division a few lines above in your script, and that operation might expect an integer input. Now it gets a floating point input, and best case it explodes and your script stops and you can find the bug. Worst case, just something, you get a slightly different result. Maybe you don't even catch it until something critical happens. And those are kind of the scariest errors in my opinion, where it's like you don't know it's wrong until you run the code, and if you're lucky it fails. If you're not lucky, the result's different, and hopefully you have enough test cases or good enough ways to detect that your results are different and they're not acting the same. So I'll show you kind of what happens here. So I'm in Python 2 right now, and let's just do 10 divided by 3, you get 3 back as a result. But let's go into Python 3 and see what happens. So 10 divided by 3, 3.33333. So okay, that's a little different. So something to be aware of. Now, they did put in a way to go back to the old behavior in Python 3. So if you do 10 divide, so 2 divide signs, 3, now you get the old result, or that forces an integer division on here. So it's good to know that you can do that. Now you might be wondering, like, okay, like, well, who really cares? Like, 10 divided by 3, maybe you really wanted 3.333 because that's a more accurate result. But let's say you're writing code that's like, okay, let's say variable foo happens equals 10, bar equals 3, and maybe I've got a statement somewhere that says, let's do foo divided by bar, let's bit shift that by 8 bits. Let's say this is like a 16-bit value, and I want to pull out the high 8 bits of this. And let's see what happens. Uh-oh, unsupported operand type for bit shift, float, and int. So let's go back to Python 2 and see what happens in here. So in Python 2, let's do the same thing, and we'll just shorten it. We'll say 10 divided by 3. Let me put those in parentheses, and then bit shift by 8. So, hey, that works. That gives me the upper 8 bits of 10 divided by 3. Let's actually get some value up there. So let's say, like, this divided by 3, bit shift by 8. So, hey, that gives you value back. So that's a pretty scary error. And if you do embedded stuff, you're doing a lot of code like this, where you're doing division, you're doing bit shifting, you're probably pulling out high and low bits, bytes and things, and sending them over to different devices. And a lot of our code did this. It's not necessarily bad, it's just it worked. But the problem is when I take that same code and run it in Python 3, like you saw, you get this unsupported operand for the bit shift operator, float versus int. So here's my tip on how to deal with this. Like you could go wild and like look at every single statement, because effectively you need to go through your code and see everywhere you use division. Do you want integer division or do you want floating point division? And you need to be explicit and figure it out. Now, luckily, they actually backported this division logic to Python 2. So I'm in Python 2 right now. If I do from __ future _ import division, then now Python 2 will use Python 3's division logic. So if I do 10 divided by 3, we get 3.3333. And if I try, for example, let's try this 10,000 or so divided by 3 and bit shifted, suddenly it fails with the same error. So let's say you've got a big Python 2 code base and you're ready to go to Python 3. Add this from future import division. Just go add it to every file. It doesn't hurt, or at the very least, any file where you're doing division. And that will suddenly flip Python 2 into this mode. And then you'll start to see things like this fail, where you depended on integer division and you might not have really realized it, and things explode. And then now to fix this, this also adds your double divide operator. So I can do, 10,000-ish or so, double divide 3. So now that's going to do integer division. It's going to give me an integer result, which is perfectly fine to bit shift like this. And now I get back a result like this. So that's cool. That's, basically how you can handle this division. It is a worrying change, but it's not hard. Just be smart about adding this from future import division. Use that. Make sure you have code that can test your code. You want to run your code paths and make sure that you've got enough tests and things to know when division and stuff might fail. But that's a good way to get around that. And then the other thing, let's see, I'll mention real quick too. So a really useful resource, and I'll put a link in the description below to this, is this really good cheat sheet on how to write code that's compatible with both Python 2 and 3. Now, you might just be able to make the case, if you're writing new code and it's just for you or who's going to use it, don't even worry about supporting Python 2, just go straight into 3. But because I write libraries that people are going to use, I don't want to force people to use one version or the other. I want to support everything. So you can write code that works with both versions of Python. And this cheat sheet page is really useful. It just gets right to the point. You can see everything in here. Let's see, I'm sure they have division mentioned in here. So if I search for division, oh yeah, here it is. It's right at the top here. So this kind of explains hey, Python 2 gives you integer. Python 3, you have to tell it to do integer division. Gives you some tips here about how to, from future import. But this is a really nice comprehensive resource. So I definitely recommend, skimming through this. It kind of explains, all the differences. And the official Python documentation for Python 3 also has a really good, porting code to Python 3 page that'll tell you some of these gotchas and things. So good resource to check out. And there are some libraries also. So there's a library called 6 that's meant to be kind of it's the common denominator between 2 and 3. So it's a library that gives you kind of a way to smooth over the differences in Python 2 and 3. So you can write code that uses the 6 library, and then internally 6 will figure out, am I on Python 2? And, are they trying to do division in a certain way? And I'm going to figure out a way to work around that, or make it all consistent at least. Now, I'm not using the 6 library myself, just because I like to minimize the dependencies in the libraries that we have, because I don't want, if you don't have to install a library, I'd rather not require it. So where necessary, I just kind of roll my own way to deal with the differences in Python 2 and 3. But if you have to do your own code, you might consider looking at a library like 6. I've heard really good things about it. So that's something I wanted to mention. So, the print statement, integer division. Another thing that tripped me up a little bit is how modules are imported. So this changed a bit in Python 2 and 3. And in general in Python, I should preface this and say, like, there are a lot of rules for module imports. There's relative imports, absolute imports. If you're running a script versus if you're running inside of a module, imports are different. So I might not have everything correct, but I'll try to kind of explain what I've seen here. So, okay, so basic imports in Python. I'm going to make a directory called test, and let's go into test, and let's make a foo script like foo.py, and we'll just say print foo script. Now when you import something, so like let's say I wanted to import another script called bar. In my script I can import bar directly, and if I have a script right next to foo.py called bar.py, it will import this script and I can access stuff inside of here. So if I make a function called bar, then I'll be able to access it. And let's just have this print out, bar. So now in my foo.script, I can reference this bar.py. So I've imported it, and then let's just call that bar function, and I'll save this. And so now I can run my foo.py, and you see, okay, there's foo.script starting, and there's bar. So it imported the bar.py, so you can see, these files. There's foo.py and bar.py next to it. And that works. Like if you just have some scripts, super simple, just throw your scripts in the same directory, you can import them. You can also create a module, which is a folder that has potentially like submodules inside of it. It's a folder that looks like a Python module, and there's a special syntax or kind of convention for how you create them. So let's remove bar.py, and let's see, I'll remove the .pyc file also. And then let's make a bar directory in here, and let's go into that bar directory. Now if I wanted to make this a Python module, the convention is you create a file called __init__.py. So let's just do touch. That'll create a blank file, init.py. And that's the little trigger that tells Python, if it finds a folder with this init.py inside of it, Python says, oh, this is a Python module. And you can actually go back in your Python code here, in this foo.py that I have, and it can import bar. And this will work because bar is a folder and it has that init.py inside of it. And then inside of that bar folder, in the init.py, I can actually throw my bar function in there. But if you're making a module, you probably want things in explicit files. So let's make a bar.py inside of this folder, and we'll just put that bar function in, the same one I had before. Just say bar. And I can save this. Now I can reference this a couple ways. So, in my foo.py, I can import bar. Now it's not going to give me this bar.bar because my init.py script doesn't reference it. But I can import bar.bar. So that's telling it to import the module bar and then import the submodule inside of it bar, which happens to be the file bar.py. And then you can call it, which you'd have to do bar.bar.bar, which looks a little funky, but this does work. This is probably not the way that you want to do this code. But what you really want to do is, have code like import bar, your module, and then, in your bar module, call your bar function. And so to do that, go into your bar module directory and edit that init.py. And you basically import in the modules that you want your script to expose. So I can, from the bar module, import the bar function. And maybe I should have given these better names. So, okay, so this will work now. If I go back to my foo.py, and if I run python foo.py, this is going to, it's saying here's my foo script, and then there's the output of the bar function. And if I go look at this foo.py script, you can see, I'm just importing the bar module, and then that init.py imports the bar.py file inside of the module, and even more than that, it imports the bar function from inside of that file, and then I can call bar module.bar function, and it runs, and everything's good. Now let's see, oops, don't save this. Let's see what happens when we do this in Python 3. So exact same code, Python 3, foo.py. Uh-oh, something's different. It's not working. You get this type error, module object is not callable. And this was another one that was a little bit annoying, and a lot of my code does this, mostly because I wasn't as familiar with the module system in Python when I first started doing some of these libraries, and I've learned a lot since then. But this kind of style, so the problem here is in the init.py. It's using something that's kind of an ambiguous import. So in Python 3, all of these module imports need to be relative, or absolute, I think works. Sorry, I should be a little careful here because, like I said before, the difference between absolute and relative imports is a little bit subtle, and I don't have it down exactly. But basically, the problem is here that Python 3 doesn't really support this style of like looking, relative to the module, a file inside of it, at least using the syntax that Python 2 supports. And from what I understand, the reason they made this change is because it's a little ambiguous right now. This from bar, import bar, does this mean import from the local bar.py file? Or what if I had a library installed that called bar, like a globally installed library? Do I really mean import from that library, the bar file, or the bar function? And so, when things are ambiguous, that's bad. It's not well understood what could happen. In Python 2, it just so happens, it seems like it will look relative to the file to pull in the bar.py file. But in Python 3, they wanted to be very explicit so that you don't have these head-scratching moments of like, what am I importing? And so the thing you need to do, you need to explicitly use a relative import here. And so a relative import, basically you can use .bar to say, okay, from this directory, the dot means look relative to this directory for a module or a file called bar, and then use that, and then from there I can import my bar function. So let's just save this, and let's go back, and let's run, here's Python 2, we'll see if this still works, and cool, it still works in Python 2, because at some point they'd maybe it wasn't even backported, maybe it supported before Python 3, but Python 2 supports these relative style imports. But you can also say Python 3 foo.py, and look at that, it works. So it's this difference between relative and kind of ambiguous imports there. So just something to be aware of. And this only really catches you for this module case. When you're in a module, to reference other things inside of that module, you have to use those relative style imports. Or if you have a script that's installed, using the setup.py, then you can use an absolute import where instead of using this ... syntax, you're giving the full name of your module. But in a lot of cases, if you're not writing a module or a library that's installed, then a relative import is kind of the way to go. So that's just another gotcha to worry about. And I think there's some explanation of this in some of these pages here, like this, let's see, this quick start guide of, the cheat sheet of the differences. Or let me go back and see. I would hope that it has some mention of this. Like, let's search for relative. Oh yeah, imports relative to a package, right? So it kind of tells you about, here's the issue, here's what you want to do, here's this new syntax that works with both of these. And again, this is the nice thing, they've put back in Python 2 a way to flip on the Python 3 behavior. So if you have a big module that you want to port and you're worried about, are things going to break, turn this on, see what happens, and make sure stuff works. So that was one thing that didn't work, and then I had to make a few changes about to support. And then the other thing is accessing I2C devices. And I've done an earlier stream on this where I've talked about I2C and how to use it with the Raspberry Pi, and I'll put a link in the description below to that stream. But I mentioned that stream how there's a library that a lot of people use and that we were using in our libraries called Python-SMBus. And it's basically in Python library wrapping around the Linux kernel SMBus interface, which is SMBus is like a subset of the I2C protocol. So it's a way that you can talk to I2C devices. And the problem is this Python SMBus library, I think it's this LM Sensors project that has it. Yeah, here we go, lmsensors.org. And unfortunately, I just lost the light. My workbench light went out, but that's okay. The battery died. You can see, but this website doesn't even work anymore. And the code for it, I think it's still out there, but maybe it's still maintained, but it doesn't support Python 3, which is kind of a major issue because, if you want to write a Python 3 library that uses I2C, what do? So what I ended up doing is I actually created my own library for I2C, and I talked about this in the earlier video. I call it the Pure IO library because I want to make it pure Python so that you don't need to use a C extension or compile any code to use this. It's just going to call interact with like the native Linux devices for I2C. And I went into a little more detail in an earlier stream where I showed how you can use the IO control call in Linux to talk to these I2C devices, because on your Raspberry Pi, let's see, lsl dev I2C, so this /dev I2C-1 device, this is like a file. You can open this, you can write data to it, you can read data from it, and that'll interact with I2C devices. Now I2C has all kinds of other like you can read and write at the same time, and you can do all these transactions and stuff. And so the way they support that, because simply reading and writing bytes doesn't give you the knowledge of like, do you want to do a whole transaction for this, or maybe you just want to send a few bytes and read a few bytes. So IO control is like a function to talk to a driver at a lower level. And so using IO control, you can do all of these low-level I2C operations just by making that call. And the nice thing is Python actually supports calling the IO control function just natively in the standard library. There's an IO control function you can import. And Python also has this library called ctypes that lets you create a chunk of memory that's compatible with C functions. So like if you need to create a struct that has a bunch of members, and maybe there's like a buffer or an array inside of there that's an exact size, you can use ctypes to create a chunk of memory that's like that, and then use the IO control function in Python and hand it that chunk of ctypes memory, and it will run. Like as far as IO control is concerned, a C function is calling it. It doesn't know that Python is calling this. And so that's what I did in this Pure IO library. I've only implemented SMBus, which is the SMBus protocol, but I've gone in and implemented using just IO control function calls. So you can actually see, from this fcontrol import IO control, this is the IO control function from the standard Python, and then I use ctypes. Now I need to do a little bit of ctypes wrangling, where you actually have to create every C struct that you're going to use in your function call. Luckily, dealing with the SMBus library, you don't need to create a lot of structs, but there's a lot of boilerplate code in here, and it's not the prettiest stuff, but it does work. And I've implemented basically all of the functions that the Python-SMBus library, I've re-implemented them using IO control. Now in the earlier stream, I kind of explained there are trade-offs to this. Like the Python SMBus library, it's implemented as a C extension that just calls directly some C functions from the Linux kernel. So it's going to be pretty quick. Like it doesn't need to do all this marshalling of like Python data into C types, memory and stuff. It's a C app and C library, so it'll just create the struct. It can throw it on the stack and it's there as soon as the program runs. There's a performance hit here in that my Python code has to go through and actually create these bits of memory, and the ctypes library has a little bit of overhead. But the big advantage is this library doesn't require having like the Python developer tools installed, like all the headers, the Python dev package. Nothing needs to be compiled to install this library. Like it's just using Python standard functions. And so that's why a lot of cases you might see libraries mention like, hey, we're a pure Python library, which just means you can install it without having a lot of these dependencies, like compiling C extensions. And for our needs, I think that's okay, because I've used this and I've actually ended up using this library for all of our libraries now, because I had to test it and make sure everything worked. And it worked great. I didn't notice any speed hits here. It's a very minuscule kind of speed hit. And I think, the trade-off is good to use this library because it's simpler to install. We have a little bit more control because the Python SMBus library doesn't implement all of the I2C protocol that the Linux kernel lets you do. Like, you can't just write raw bytes to an I2C device. And there are some devices that require, they don't use this SMBus protocol, but they do use I2C. There's like the little humidity sensor actually I wanted to use that, you need to actually talk to the I2C device file and read and write raw bytes with it. So I have the capability to do that in this library versus if I was using Python SMBus, you can't do it. You're gonna have to do it yourself. And so I think over time, I think it would be cool to take this idea further. Now I mentioned here, and I should update this README, but I'd like to add SPI support and maybe even just generic GPIO access, like using the sysfs interface to GPIO, all pure Python. So only using IO control and basic block level file read write commands for this. Because it's nice to have an option if you want a library that doesn't have a lot of dependencies to be able to do that. But for now, because I wanted to get stuff on Python 3, there wasn't a Python 3 SM bus library, so I said, well, let's just create this little pure Python one as a start. So I did that, and it's and I've switched over all of our libraries to start using this one by default now. And you don't actually have to even worry about this. We have a little GPIO library that's like an abstraction layer on top of the GPIO libraries that you might use on Raspberry Pi versus BeagleBone Black versus chip microcomputer or whatever fancy new small board computers come along. We can add support to our GPIO library, and it's the one that uses this pure IO library, and it imports it automatically, so you never have to know that this is being installed. But it's there, and our libraries use it now. So now I wanted to go through and let's play with a little bit of the hardware that I have right here. And I'll show you that it works on both Python 2 and 3, and that it's not too crazy to use this stuff. So let's do the MCP 9808 sensor first. So let's go back to our kind of list of all the Python code. And this was one of the newer libraries that has its own GitHub repository. So let's go to its repository, and I'm going to grab the link, the link to download it. And so I'll clone the code for this because I want to get the example code. And I'll show one, oops, I need to install git, apt-get install git. And I'll show an example of a pip installed library also that, because I put all these things on the Python package index, you can install it with the pip package manager, but you don't get the example code like I mentioned before. So, and in a lot of cases, you probably want that example code to get started with. So, okay, so git is installing. It just takes a second here, and we'll be ready to go with this. So, and if folks have questions or whatever in the chat, feel free to throw them in, and I'll try to answer them a little bit as we go here. So, and okay, almost done installing here. And also too, just in general, if you have code that you're thinking of porting to Python 3, for a while I kind of put it off because I knew about all these changes, like the division change, and I know in my code I've written things that depend on division, so I was kind of expecting a lot of pain. But honestly, it was a lot easier to port the code to Python 3 than I expected. Like, most things just worked. Luckily, things that didn't work failed in ways that I could catch, or that I was able to notice. Like, I didn't run into any problems where it was like, wow, this is working totally different than it does in Python 2. If something didn't work, it at least failed. But like I mentioned before, like there are cases where your code might still run in Python 3 but behave differently. Okay, so git's installed. Let me clone the repository for this. And then the standard steps to install a Python library, I'll show you. You have to run the setup.py file that's included, and there's an install command. Now the big thing, remember, like I said before, Python 2 and Python 3 on the Raspberry Pi have totally separate libraries. So if you install a library, you need to install it for both Python 2 and 3 if you're going to use it on both those versions. So I'm going to go into the directory that it just created, and you can see there's a setup.py, and then the convention in Python, you run your setup.py, and I'm going to run this with Python 2, so just normal Python, setup.py install, and this will go through, and this is installing some of the dependencies here, and we'll kind of see it does its little thing here. You can see actually here is where it installed that pure IO library, so it picked up the dependency and installed it. And so, okay, so we're good to go. And I didn't mention it, so I wrote my own I2C library. For SPI hardware, things that use the SPI interface, that uses a module called python-spydev, and luckily that one supports Python 3, so I'm just using that. It seems great. Someone recently, I think in the last year, took it over because it broke in Raspbian Jessie. So thanks to whoever took that over. Good on you to make this stuff work and to make it work with Python 3. So that's really cool. So everything's installed for Python 2. Let's do the exact same thing for Python 3. So sudo python 3 setup.py install. And this will install the script. And you see it's downloading all the libraries again. And that's because Python 3 has its own little set of libraries. Now, way off in the future, I don't know if this is going to be the case. Like Ubuntu, actually today, I think, just released, or maybe tomorrow, 1604 LTS, the latest version of Ubuntu, the long-term stable release. And they actually made the switch. If you install Ubuntu 1604 LTS, when you run Python, you're going to get Python 3, and that's the default. And it causes a little bit of pain, but you know it's the way forward. Like, you know, Python 2 is not going to be supported for much longer. So you know, something to be aware of that. And eventually, you know, Raspbian, I'm sure at some point down the road is going to make the same switch. I mean, once Debian Linux makes the switch, then I'm sure Raspbian will pick it up too. So okay, we've installed the library. Now let's go into the example code, and there's a little simple test, and we'll just look at this file. It's pretty simple. You know, it imports the module, creates an instance of it. It's an I2C device, so you don't need to do a lot of stuff to make this work. You know, you just call basically get the temperature function for this. So let's try it. Let's do sudo python simple test. So this is Python 2.0, and we'll run this, and it prints out the temperature. And so if I hold my finger on the sensor, you'll see the temperature jumps up. So it's, you know, like 80 degrees or so. You know, real nice little sensor. This is the MCP 9808 sensor. Great if you need like a little high precision kind of ambient temperature. So okay, so let's cancel out of this. Let's do the same thing. Let's do sudo python 3 simple test.py. Here's the big test. We're using Python 3 now, and awesome, look at that, it works. Same exact stuff. You know, I hold my finger on here, it gets hotter. So that's cool. I mean, you know, no drama. You know, there's a little bit of drama when I ported this over, but honestly, those things I mentioned, the print statements, division, and relative module imports, that's really all I had to fix to make stuff work on Python 3. So that's cool. That, you know, this stuff works. It's using that little pure.io SM bus library internally. Now I'll show you a little secret. I haven't really mentioned this in much of the documentation, but if you want, you can go back and use the old Python SM bus library. So in this simple test, you can change this to use the SM bus library if you need to. So there's a parameter to the initializer. It's I2C underscore interface, and you need to pass in, so you want to import the SM bus library. So import SM bus, and then you need to pass in the SM bus class. So SM bus module dot SM bus with kind of uppercase SM, uppercase B for bus. And this is telling it, for my I2C interface, use the old SM bus library instead of my new pure.io library. So I can save this, oops, and I can exit out of here. And I think actually, now I have to use Python 2 because Python 3 doesn't support this. And I think this will actually fail because I don't have SM bus installed, but let's see what happens. So yeah, I don't have it installed, but if I install it, apt-get install python-SM bus, then this should run, and we'll see this will work. So I wanted to put this in here because I knew, like, you know, this is a new library, things might not work. Maybe there's some weird little thing that, you know, the old SM bus library works with. So if you do run into a weird error and you're using this new library, you can change things to work with the old library. So let's try that code, and now it's working and it's using the SM bus library. So, you know, it's smart to have that option in case you need it. So, okay, so that's cool. So I2C stuff works. Let's try that little MAX31855 thermocouple sensor. Now that's a SPI device, so it uses the Python SPI module to do kind of low-level access. But let's go in and let's grab the GitHub code for that. So that's this library right here. And so exact same kind of setup procedure. So let's git clone and paste that in there. And this will download the code. And then we go into that directory. Oops, max. There we go. And again, install for both Python 3 and 2. So sudo python setup.py install, and sudo python 3 setup.py install. And then I can go into the examples. And in this one, there's a little simple test example. And I need to slightly modify it because you can use a hardware or software SPI connection. By default, the example code here is using a software SPI connection, but I have it wired up to my Raspberry Pi using the hardware SPI interface. So this is the line that I want to uncomment. So save this, and then let's run it. Sudo python simple test, so Python 2, and we'll see if this works. So yep, there it goes. And so this is the thermocouple right here, and when I hold my finger on here, you can see the one to look at is the thermocouple temperature line, kind of this line here. And so you can see, it's 86 degrees or so. Internal temperature is kind of the temperature, I think, near the chip itself. And like thermocouples work, I think they look at like the difference in temperature, difference in, maybe it's like difference in voltage. There's a guide on the learning system for thermocouples that you should go look at to see how they work. The thing I like about thermocouples is they're really fast. So like, notice how it's at like 78 degrees or so. And then when I put my finger on here, boom, it shoots right up the next reading to 85, 86. So really quick to change because there's not a lot of metal here. Like my finger touches the metal, instantly increases the temperature, and it picks it up really fast. So really handy devices. But okay, let's try this in Python 3. So again, we should see no drama. Like there it is. It's all, we're getting temperature. I hold the probe and it gets warmer. Everything's great. So that's cool. I2C, SPI, Python 3, all happiness, ready to go. Nothing really changes as far as how you install these libraries. You're just good to go with Python 3. Now the next thing, I'll show the pip install package. So let's light up these little neopixels here. No, sorry, they're not neopixels. They're WS2801 RGB pixels. So let's do this. So the module for this is called, the old module was called LED pixels. But I went through and I wanted to make it more explicit. So I created a Python WS2801 package that's, it works with the WS2801 style pixels. It might work with other pixels, anything that has a SPI-like interface with a clock and a data line, and it just expects 24 bits of RGB color data. This should work with in theory. Now to install this, so like in this table I listed, so there's the Adafruit-WS2801 package. So let's do sudo pip install, and remember this pip is Python 2's version of pip. It's not Python 3. If I want Python 3, you have to do sudo pip3 install, but let's do sudo pip install Adafruit-WS2801, and this will actually go and install the module. So that's kind of cool. Like you don't need to clone it, but the thing is, like, it's installed globally and you don't have the little example code in here. But it's not hard. You can go to the GitHub repository and like here's an example script. So let's grab like, how about the rainbow example? Let's grab that, grab the raw code, and we'll copy this. And then let's make a rainbow.py file. Let's just paste in the code for this. And then I have these wired up. You basically set the count of pixels and then the clock line and the data output line. So that's the way I have these wired. So I'll save these. And then let's do sudo python rainbow.py. And you can kind of see these things are lighting up and it's doing a little rainbow cycle. Only the first 10 pixels here. So that's cool. Pip install, pretty easy, good to go. Now, unfortunately, I just noticed, so if you can try pip3 install Adafruit-WS2801. It looks like this fails. Interesting. I don't have a sudo apt-get install Python 3-pip, I think is the name of the module. Let's make sure. That's weird. Why is pip error? Sorry. I did have it right. Sudo pip3 install. I need to tell it the command to do. And then the module to install. Now you can run this. You're going to see it fails. Unfortunately, so I'm using this thing called Easy Setup, and I'm not even sure if I need this anymore in our libraries because like long ago, Python didn't have this setup tools, and this Easy Setup was a way to import it. The funny thing is this is failing because of, I'm pretty sure, one of these relative module issues. It's a little weird that I didn't really notice this until the pip3 install, that I attempted. So right now pip probably doesn't work for Python 3, but I'll go through the next few days and fix this up and push out, updated packages. So for Python 3, and just in general, I think it's smarter to install a lot of these things from GitHub, from their source code, because you get the example code, and it's a little easier to know what you have installed. But just to be aware, if you try pip on Python 3, you might run into this error right now, and I'll fix this up later. So let's git clone the repository for this and paste it in here. And then let's go into this directory, WS2011, and then I need to install it for Python 3. So run setup.py install. And then I can go in and run the example. So if I go into the examples directory, now Python 3 run rainbow.py. and we'll see. Oh, interesting. No module named RPi. That's kind of funky. Huh. Well, I guess there's more stuff that I need to investigate for this. This was working before, so live coding. I'm not going to dive in and try and figure this out. It's already kind of run for an hour. But anyways, this will work on Python 3 after I fix this. So, like you saw, the other libraries are kind of working, and it's all good to go. So yeah, I think I'm going to wrap up the stream, and we'll call this good. If you have some questions, throw them into the chat right now, and we'll kind of go through these. But I think it's, like I said, this should be the green light to go forward and start playing with Python 3, using our hardware libraries. And this page, the old Raspberry Pi legacy Python code, big change. The code's not there anymore, but it links to the new location. These are all good to start using with Python 3. And like you saw, there might be a few little issues I still need to fix for some of these, but in general, these are ready to go, and all the major things are good. And like this page says, if you do need the old code, it's in a legacy branch. You can still get to it down here. So it's, I realize that not everyone can immediately switch over and start using stuff that's new. So, okay, so let's go back to the main view here, and let's see. So, okay, so one question was, what's the standard language for Raspberry Pi? Good question. So, by default on the Raspberry Pi, when you run Python, you get Python 2.0, 2.7.9 it looks like. And if there is a standard language, you might consider Python the standard language. The Pi comes with Python. All the Raspbian distributions have it installed by default. It installs like the RPi.GPIO library, which is the Python library. So it's good to go with that. But you can use like Node.js. I think there's like this Node-RED is like a Node.js based little programming environment you can use on the Raspberry Pi. Nothing wrong with using C and C++, like, the compilers are there to use those. But if you're just getting started, and especially if you're new to programming, I really like Python. I think it's a good language to start with. And the Raspberry Pi, everything works pretty well with Python. With Adafruit, with a lot of the libraries we've kind of chosen Python as like, the default language for all of our code that we publish for Raspberry Pi, just because it's the easiest to get started. You can easily install Python and the packages and the dependencies and stuff for it. But there's no reason why maybe in the future we might look at other stuff like Node.js and whatnot. So I think that was it. I think that was the last question. So thanks a lot for watching. Subscribe to youtube.com/Adafruit. You can see this video, all kinds of other fun projects. Subscribe to twitch.tv/Adafruit, and you can see me stream this live. And I like to do at least 2 live streams a week, but I'm starting to do like 3 live streams. So I usually do a stream on Monday to like look at interesting Pi software. And this Monday, I'm thinking of looking at something I keep hearing a lot about. It's called HomeAssistant.io. And it's a really neat little kind of home automation hub that you can run on a Raspberry Pi. And it can connect to all of your crazy little smart devices in your home. And you can do interesting little workflows of like, when a temperature sensor changes, maybe turn the color of my light bulb to something else. So I wanted to play with that because there's, a lot of cool stuff you can do with the Raspberry Pi. So look for that Monday. Tomorrow, Friday, I usually do a stream on like a longer series. And so I've started one last week, the Raspberry Pi Talking to Wi-Fi Things series, where I've got, little Wi-Fi boards like, the ESP8266, the Feather Huzzah that we have. And so I've started a series where how do you get one of those boards to talk to a Raspberry Pi, like a Wi-Fi microcontroller, and looking at like basic socket programming and stuff like that. So tune in tomorrow and you'll see a new video in that series. And then otherwise, all throughout the week, we've got Desk of Lady Ada, knowing page rev layer by layer, all kinds of cool content happening at Adafruit. So like, subscribe, comment, do all that fun social stuff. That'll keep us all happy and going. And thanks a lot for watching. And I'll see you guys tomorrow on Friday and then Monday again. So Tony from Adafruit, and I'll see you later.